Welcome to Mastering Solutions. In this problem, they want to figure out what is the horizontal distance between the shark's starting and ending positions, and then they want us to find the total distance that it swam and then the time that it took. So let's draw a picture of what's happening. Let's say we have the surface of the water right here. And then the shark started, they said, from 50 meters below. So this is 50 meters. And it swam at 0.85 meters per second at a path tipped at 13 degrees above the horizontal until reaching the surface. So 13 degrees above the horizontal until it reached the surface. Okay, so now for the first part, what is the horizontal distance that it swam? That's right here, and that is obviously in this triangle, the adjacent. We have the opposite and we're looking for the adjacent. We'll be using tangent or TOA, obviously. So tangent of the angle is equal to opposite over the adjacent. And we want to solve for the adjacent. So we'll multiply both sides by that, which gives us opposite is equal to adjacent times the tangent of theta, but we want the adjacent. So we'll divide both sides now by tangent of theta. So tangent of theta. So rewriting it down here, we have the adjacent is equal to opposite divided by tangent of our angle theta. So now when we plug that in, we have adjacent is equal to the opposite, which we said was 50 meters, divided by tangent of the angle, which is 13 degrees. 50 divided by tangent of 13 is 216.57 or 216.6. So 216.6 meters for part A of the horizontal distance that the shark swam right here. Now moving on to part B, they say, what is the total distance that the shark swam? So the total distance that it swam was here where it started up to here where it stopped. So we're trying to find the hypotenuse in the triangle now. And we can do it one of two ways. You could do Pythagorean's theorem since we have the bottom leg and the side leg, and do a squared plus b squared equals c squared. Or we can also do trigonometry. So I'm going to use trigonometry. Either way is totally fine. Like I said, it'll give you the exact same answer. So I'm going to use sine since we have opposite. So sine of the angle is equal to opposite over the hypotenuse. We're going to be using the exact same math that we did up here, so I'm not going to show it again. So that will give us the hypotenuse is equal to the opposite divided by sine of the angle theta. So now when we plug that in, the opposite was 50 divided by sine of 13 degrees. And we have 222.3 meters is the total distance that the shark swam. And now the last one for part C, we need to find the total time that it took. So to use that, we'll be using the velocity equation. So velocity is equal to the change in the distance divided by the change in time. We want time, so let's isolate that by multiplying both sides of the equation by time, and that gives us delta x is equal to v times delta t. And then we want to isolate, of course, t. So now we have delta t is equal to the change in the distance divided by the velocity. So now we can plug in the distance that we found, the total distance right here, 222.3. And let's come down here and write this. So delta t is equal to 222.3 meters for the total distance divided by the velocity. And the question said that that was 0.85 meters per second. We have meters per second divided. So we are dividing by a fraction. So if we multiply by the reciprocal, now the meters will be opposite. So the meters will cancel and we'll be left with seconds, which is the unit that we need. So it's a double check that we did our math correctly. So now we have 222.3 divided by this velocity is 0.85, which gives us a time of 261.5 or 260 rounded seconds for significant figures.